Alright, let's look at the homework 5.4, 5.5, problem number 15. Alright, so first, sketch the region bounded by the graph of these functions. Alright, so here you have exponential function, and we have a rational function. Exponential function, this is especially increasing function, so first picture doesn't look like it. Alright, second one looks promising, and the third one, alright, the graph is both negative, so below the x-axis, so this cannot be it. And here, fourth one, you know that negative 1 over x is going to be a negative, so it should be below the x-axis. So we can see that this is going to be the correct picture, and going from 1 to 3, that matches up these guys. Right, so this is the correct picture. Right, then what we want to do next is we want to find the area. Right, so let's do that. Alright, so in order to find the area, so what we need to do is we want to set up the integral. So area A, so this is going to be our area A, and the integral is going from looks like a 1 to 3. So lower limit is 1 and the upper limit is 3, right? Then the top curve is this guy, which is the exponential function. So you have e to the 0.5x, right? Then minus, right, negative 1 over x. So it's double negative, so minus negative, so it's going to be, I'm going to put the plus 1 over x. Alright, then with respect to x, so this will give us the area of this shaded region. Alright, so let's do that. Right, so to find the antiderivative of e to the 0.5x, I'm going to actually do it over here separately. So what would be the antiderivative e to the 0.5x? Right, so I'm going to do a little substitution here. Let u be 0.5x, right? Then if you take the derivative of u with respect to x, you get the 0.5, right? Then you take the reciprocal of both sides, you get the dx over du is equal to 1 over 0.5, right? Which is the same thing as 2. Right, then multiply through by du. We get dx is equal to 2 du. Right, so this integral is going to be integral e to the u, and the dx is 2 du. Right, but this is 2 is just right in front. Antiderivative e to du is e to the u, right, plus some constant c, right? Then we can just put this guy back to 2, and here u is 0.5x plus some constant c. Alright, so here, if you want to find the antiderivative, we already found it. So e to the 0.5x is actually 2 e to the 0.5x. So it's 2 times e to the 0.5x, and plus antiderivative of 1 over x is natural log of absolute value of x, right? Then you're going from 1 to 3, right? So this is going to be equal to, right, plug in 3 here, so you have 2 e to the 1.5 plus natural log of 3, and minus and plugging 1. So it's a 2 e to the 0.5, right? And plus natural log of 1. Right? Remember that the natural log of 1, this is 0. So we're just going to get, okay, I'm going to just put, let's see, these guys together. And I'll just pull out the 2. So 2. And you have a e to the 1.5 minus e to the 0.5. Right? Then you have plus natural log of 3. Right? It doesn't look pretty, but hopefully this is the correct answer. Right? So let's type it in. Right? So we actually we have to round the answer to 3 decimal places. Right? So let's do that. So I'm gonna bring up the Geogebra. Alright, so we need to find the value of 2 times e to the 1.5 minus e to the 0.5, and then let's see, was it minus? Actually plus, right? So plus natural log of 3, right? Then 3 decimal places. Hit enter. Right? Oops. Hit enter. Enter. Right? So we got the 6.765. Right? So let's type it in. So 6.765. Right? So let's submit for testing. Alright, it came back and looks like we got the graph correctly and the area correctly. Alright, that's it. I hope that this was clear.